Alright, my name is Jamb Utme. Today we are looking at physics Jamb past question year 2017. Alright, so we're starting from question number 1. Question number 1 says, which of the following is incorrect formula for a body accelerating uniformly? So we're talking about uniform acceleration. So ideally I will just point the answer to you, but I want to give you some of the knowledge, some of the proving behind this formula. Note that no one will ask you to prove any formula in Jamb, so don't waste your time trying to impress anyone. Alright, so just go straight and pick your answers. I just want to give you this understanding so you have an understanding of how this formula came about. Okay, alright, so let me have it like that. So for a uniform acceleration, the basic formula there is A equals to V minus U over T, where V is what? The final velocity, U is the initial velocity, and the time T is the time taken to move from one point to the other. So when a body starts moving, it might start moving slowly, okay, then it moves with a higher speed, then finally it comes to a stop. So the final velocity in which it's moving with is called the V, that's the final velocity, then U is the initial velocity, T is the time taken for the movement. Okay, so from here you will agree, if I call this one equation 1, you will agree with me that if you multiply A and T, you have AT. This will be equal to V minus U. Alright, no confusion yet. Then you have V equals to, if this comes to meet these guys, you have this to be U plus AT. Then I can call this one equation 2, even if it's just a simple derivation from equation 1. Okay, so we have what we call average velocity. Average velocity is equals to final velocity plus the initial velocity over 2, depending on how many velocities in question anyway. So if you have a number of movements where you have a number of velocity, you are actually going to be dividing the number of velocity, you sum them up, divided by their numbers. In this case, we are looking at two velocities, the initial velocity, the final velocity, and then we divide it by 2. That's what we call average velocity. Okay, so you know that your velocity actually is equals to distance over time. All right, now for a uniform acceleration where you have two velocity in question, then we are going to be using V here as what? Average velocity. Okay, so from here now, my average velocity will be equal to V plus U over 2, which will be equal to S over T. No confusion yet. Okay, now if I make the T the subject of the formula, so here you have V plus U times T. If you cross multiply, equals to 2S, which implies that T equals to 2S over V plus U. Is that correct? Now I'll call this one equation 3. Okay, now from equation 2, equation 2, you have V equals to U plus AT. Okay, now in place of T, substitute equation 3. Since T is 2S over V plus U, then you have V to be equals to U plus A. So in place of T, I'll be using 2S over V plus U. So all I need to do now is just expand this equation. So I've been able to eliminate T, just in case you don't have time. You have initial velocity, you have the final velocity, and you have the distance taken. So you have to calculate one of them. You don't have time. So T is no longer in place, right? So we have, from now, I can cross multiply with V plus U. So that will give me V into V plus U equals to U into V plus U. You multiply every through by what? V plus U. And plus here in 2S V plus U times V plus U. You realize that V plus U, let me write that properly so you could see it, times let me put it in bracket, v plus u. Now this v plus u would cancel. Let me use red pen there. This would cancel this. All right, so if that cancels that, then you have this one. Let me return to my original pen. So I will have v times v, that will be v squared, plus v times u, that will be uv, equals to u times v, that will be uv, u times u, that will be u squared, plus 2a times 2s, that will be 2as. Is that correct? This one is gone. Then here, let me just collect the like times. Okay, simple mathematics. V squared plus uv minus uv equals to u squared plus 2as. You will agree with me that the same way that this one negates this, then I will have v squared equals to sorry, this is supposed to be u squared, not a squared. I said it, but it's just my mouth didn't get it. This is u squared, so u squared. So we have u squared plus what? 2as. This is another standard equation of what? Of motion. This is a standard equation of motion. This is another standard equation of motion where v velocity is to be determined. You have the initial velocity, then you have the distance, time is not given, you have the acceleration, then you can use this equation. Okay, so I can call that one equation 4. Okay, so let me move on to the next page. Now in equation 4 I have v squared equals to u squared plus 2as. Is that correct? Now if s is not, if the final velocity is not known, I have the initial velocity, I have acceleration, I have x, then I have time equally. I'm just to look for one of them, but final velocity is not known, so I need to substitute for what? The final velocity. Okay, so from equation, what do we call it? Equation 3, you realize that we have t to be equals to 2s divided by v plus u. T from equation 3, from 3, t equals to 2s divided by v plus u. Is that correct? So all I need to do now is eliminate my v, so I could have I will just make v the subject of the formula. All right, so here I have t times v plus u to be equals to 2s. Is that taken? All right, so I'm just trying to break it down for you so you have the true understanding of what we're doing. So from here I have my vt plus ut equals to 2s. Okay, so from there you have your vt to be equals to 2s minus ut. Is that? Then your v, if you divide both sides by t, then you have your v to be equals to 2s minus ut all over what? All over t. Okay, now let me put this into perspective now. Okay, so from v, initially where we have a equals to v minus u all over t. Is that taken? You know that we said v equals to from here we said v equals to u plus at. U plus at. Now let me put this here. Let me call this one equation 5. Okay, so let me put 5 in equation 2, the equation that we had initially. So we would now have, in place of v, I will use 2s minus ut over t equals to u plus at. So there's no v anymore, so I can multiply through by t. So if we multiply through by what? By t, then you have your 2s minus ut equals to ut plus at squared. Is that correct? Simple. All right, so from here now I have my 2s to be equals to, take like times. If this one travels from here to here, then I have this to be equals to ut plus at squared. Is that correct? So I have my 2s to be equals to 2ut plus at squared. All I need is making s the subject of the formula. Then I divide through by what? By 2. So if I divide through by 2, then you have your 2s divided by 2. You have s to be equals to 2ut over 2 plus at squared over 2. This simply gives you s to be equals to, this cancel this, you have ut plus a half at squared. So this can go on and on. This can go on and on like that. So what the question is saying is you should pick from this equation I have derived for you. So you have a number of them. So we say which one is incorrect. So let's look at the option. Okay, so if you look at the option, you have one of the option is not so clear, so I don't know what it means. So we have v square equals to u square plus 2s. They're asking for which one is incorrect. You will know yourself that this is correct. V square equals to u square plus 2s, one of the equations that I have just derived for you. And then you have another option that says s equals to a half ut plus at square. You would tell me in a second if it is correct or not. Another one says v squared minus u squared equals to 2s. This equation and these are actually the same thing. It's just taking this one to this side, so it's the same thing. So this equation is not correct. This one is not correct. It's supposed to be s equals to ut plus I have at squared. This is incorrect. This is incorrect. This is incorrect. Okay, so that's the answer. This is not correct. All right, so let's move on to question number 2. Question number 2 says, which of the following is not an electromagnetic radiation? Which of the following is not an electromagnetic radiation? So we're giving options. We have X-ray, we have radio wave, we have sunlight, we have sound wave. Okay, so simply sound wave is not an electromagnetic wave, it's a mechanical wave. Okay, so because it requires a material medium for its what? Propagation. What is a sound wave to start with? A sound wave, you know, it's sort of a disturbance that travels through a material medium. Are you getting it from one point to the other? All right, so it's not an electromagnetic. So what do we have in electromagnetic radiation? We have the X-ray, we have the gamma ray, we have the ultraviolet, you know, we have all sorts of rays like that. So if you look at the option, you have first one, you have the X-ray, right, which is an electromagnetic radiation. You have the radio wave, which is microwave rather, which is an radio wave, which is an electromagnetic radiation. We have the sunlight, which is an electromagnetic radiation. Sound wave is not. So your electromagnetic radiation example, I will just give you an example of them. The radiations examples, you have your X-ray, all right, so you have your radio wave, you have your microwave, you have your radio wave. Okay, so you have the sunlight. Okay, so you have the gamma ray, extra, so we have the infrared as well, infrared. Okay, I'll just give you some examples there. So sound wave is not part of the pool. So question number 3